So this was what we were able to do yesterday because of time and all of that. So it was just remaining to replicate this same feature on this port on the PCB, and then the second one here, right? And then that would be probably, all we would be doing for the enclosure, the bottom enclosure. Right, we have the top, we have the bottom. So as usual, we know that we have to activate the component that we are about or wish to work on. So one good thing that you could also do, that Fusion allows you to do, is since we were able to split this component into. Someone is saying something.
Go ahead, please. Go ahead.
So since we are able to split the components into top enclosure and bottom enclosure, so Fusion can allow you to convert your body, right, into a component directly. And so from that point onward, every other thing you will be doing will be tailored to just that component. Just as we know by now, I believe we understand how the components work, components and sub-components, right? So this is what we are going to do. Click on the top enclosure, right click, and you say create components from bodies. You notice that we have a component now called top enclosure, no longer a body. A component that which you will open up and then find the body still inside, right? Just think of this as your container, housing your construction, your origins, and everything that has to do with maybe what you'll be working on to get to modify this body, right? Then you right click on the bottom as well, and you convert it to a component. So one of the reasons why we do this is because you have a much degree of freedom when designing and you're working with a component than when you're working with a body, right? So now we have the bottom enclosure and the top enclosure as a component, and both of them are sub-components of main enclosure. I believe we are seeing how that works now. So what we are going to do is to instead of activating the main enclosure, we are going to activate bottom enclosure. All right. Automatically, the top is grayed out. I explained this yesterday. So we still have our PCB file as well. Okay, so we could just use the I command, the visibility button, to turn off. You're seeing some form of wireframe view, which could also, cause a lot of complications if you're not really good with being able to, differentiate both of them. So you could just make life easy for yourself. You turn off the top enclosure, not deactivate or activate, just the visibility. So it's there, but you're not seeing it on your GUI. That's all you've just done, right? So you head on to, or you orient the enclosure in this direction. Like I said, you could use the model geometry as your plane. So instead of going ahead to bring in plane, you could just create it directly there. And of course, there are reasons why we do that. I told you that for this kind of work that we are, trying to get out, the consequences are not that grave. So you could, follow that approach, right? And it's also very easy and faster for you. So you click on this surface, right click, and say create new sketch, right? So the next thing you want to do is to know where the port is exactly. Yes, the port is on the PCB, but where will the port be when mapped onto this face you're looking at? So what do I do? By now, we are also very, these terms are things that we should be used to. So you just go over, you project, right? You project this, you need that edge, right? So I will just turn off the body for now, so it will be easier for us, just for a moment. I'll turn off this body, so I could see and tilt with my view cube, zoom in, pick up this place, and this one. And remember my rule, it's always good to project just the things that you require, not projecting the entire thing, because it could mess up your work, could make debugging very difficult for you, right? Imagine trying to click on this page. You will probably still have the same thing I'm doing, but you're having very unnecessary projections onto your sketch, which you don't even have need for, except you do have need for them, right? So for this other one, we'll probably just pick up this face. Then once we are done with that, what you will notice, you click on OK. Now we can tell the PCB to, just stay one side for now. So you could just turn off the PCB and turn back on the body. So this is what we have been able to create. But take note, this is not on this face. This is actually on the inside. This is what I mean. It's actually on this part, right? So I'll just turn that off again. And then zoom in to see that there's consistency in the loop, of which by now we know that it's not there because there are some points where there's it's disjointed. So I just quickly pick up my tool, my line tool, and close up, this opening. And I check if I will see another one. Same thing on this corner. Close it up. Move in. You can see that this is selectable now. So that means we are good on this part. All right. So the next one we are going to do is to turn back on our PCB so that we know exactly where what we just projected stopped. Remember, this is the board. If you could still picture how our PCB looks like. It's all looking wireframe now. But if you could still picture, this is the surface of the PCB, right? 1 minute. Let me turn this off. This is the surface of the PCB, right? So this PCB you're seeing now, this line where you see I've just highlighted, tracing it down to where there is where it's is on this other part where you have the port. That's what I'm talking about. So this is the line I'm referring to. So we need that guy as well. So you use what? Projection. So this time around, I'll just click shortcut P on my keyboard and then select that line. To tilt it a little bit, so you can see your selections. Click on OK. I don't want this much confusion, so I'll just turn off the PCB5. And this is what we have. This is what we've created. The purple line up there and this one. So what are we going to do next? To do what? An offset. We pick up your offset tool. Or rather, since we are trying to create a wall around the port, and that wall will actually have a thickness which we want to also be exactly the same thickness as the thickness of our entire wall. This is what I mean. The thickness of we want the thickness of what we are about to create to be exactly the same as the thickness of this other wall here. So a better way will be what? To come over and use you call in a rectangle. You just do a freehand, just pick it, drop at some point. Now you use your dimensional constraint, pick on the sides, you pick on this side. Now remember our parameter is called shell, right? So we just put it in the shell. Select. Right, same thing. Same trick I taught us yesterday. Instead of putting it, I just click on the existing dimensions so that they become what? Related. So once I change, everybody changes. Next one I will also do from this point to this point. Theta it here. That's what we've gotten so far. Now I explained the reason why we shouldn't have this going beyond, because this cannot, what we're about to create will also have its own wall and it can't go beyond the PCB. This purple line under, which we projected a few minutes ago, came from the PCB. So this means this is where the PCB stops when coming from the top. This is the first, this is the face that you have collision with. So it means we cannot go beyond this point. So I just pick up my constraint, a geometric constraint now called coincidence or collinear rather. Pick it up, select these points and select these points. We've gotten that. Now we still pick on our line tool to close up this other loop. Just select and drop, even if it's not straight, just click, drop. Then you could use your vertical, horizontal constraint to align, make it straight. So this is what we have. So what are we going to do next? We can finish up that sketch. And of course, it's not going to be a new thing that what we've just created will be, because bottom enclosure is active. So under bottom enclosure, we'll have this sketch, we'll have this. So I can just come here and for professional practice, we'll call this port 3. We did 2 ports before, so this could be your third port and port 3. So once you look at them, you know what's happening on your design, right? So you can turn back the body itself. This is what we have so far. So you simply drill, right? Just do a cutout. For consistency, you could also say like the distance of that cut should be equal to what shell. If you could picture what that means, minus shell for convention, it means that whatever the shell thickness will be, this cutout will always align with it. So that's a very, very good practice, except that is not what desired, because there are also cases where you don't want it to be that way. So that's why we tell you that it's not just one way. It's just you knowing if what you're applying is the best way for achieving what you're trying towards, your aim. All right, so we've done that cutout. So now if you turn on the PCB, yes, there will be a direct direct communication between the external and the internal, but you can already see that there are holes here, right? This is not good. It's not good for business. It's not good for the design. It's not good in every way you want to look at it, right? Except by the PCB design, that's on the electrical side of things. This has been flushed to this PCB, where you have the edge of your PCB, right? So now, since you don't have this flushed, what do you do to take care of this situation? That is where all of this we are doing yesterday came in, right? So on the inside, you can't have any gap, but on the outside, it still looks as if is a straight passage, but in reality, it's actually what's been covered. So that's the reason for what we have just done. And so we are also replicating that same thing here. On that note, I will just turn off my PCB, turn on my ports, do what? Extrude, and pick just this port. So you also understand the reason why I had to pull this line down here. Because if I don't, that means I will need to pull this one. And when I pull this and pull this out, it's going to collide with the port. Let me turn that back one. Look at the ports. You already see that there's going to be a collision. A little bit. So down here, this is already on, it's already passing through the PCB board itself. So it wouldn't work. That's why I decided to use this approach. So I will just cancel this, turn back off my PCB, zoom in, and pick up the one that looks like an L, leaving this other line under. So I put this out, and there was a rule we also created, FDM rule. We called it FDM edge. A funny name though, but of course we also see how it works, or the reason why we did that. So by magnitude is actually 3 mm, right? I just had to use FDM so that you understand this movement. I'm constrained on how I could draw this, right? Not just drawing for drawing sake. So I'll go back there to correct that to what? Okay, just type that back in FDM. You click on OK. Operation join, please, because you don't want it to be a separate body. It's part of the bottom enclosure. So you just click on OK. You don't need that sketch no more. So this is what you have so far. One last one. The other ports. So we just repeat the same process. Same thing here. Oh, sorry, let me cross-check that. Sorry, this other place. So create a sketch on this other side. Turn back off, right click. Create sketch. It's quite easy. Next thing was projection. So turn this one on. You can turn off your body. Zoom in. P for projection on your keyboard. So select that face. select that edge and the bottom. By now, we already know what's happening. So we just turn off PCB, go over to close all open loops. So line, I'll pick up the line too. Right, escape. So it's now a region, not just a line. So what do I do next? We also need the PCB, where the PCB cuts across that line, or where it moves under the line rather. So same thing, P for projection on the keyboard. Move in, you pick that guy up. So let's okay. You can turn off the PCB now. So this is what we have as well. Now this is where you as a designer too could also maybe liaise with your electrical designer. I'm like, maybe we shouldn't have this port all separated. 1 year, 1 year. Maybe we should gather them around and all those kinds of stuff with tangible reasons. Don't forget you're creating a product that you want your user to be happy with himself when using it, right? So I'm also pointing out these things. What you're saying here is not casted. It's not as if it's casted on stone. Like you must always follow what's that approach, but the thought process is rather, and the things I really want you to see. So you just pick up the rectangle, do this as usual, default dimension. You pick that up. Value will be shell, right? Enter. Same thing on this part. Tie them up with the relationship. So I'll select this existing dimension already. So they become one. Same thing, because I desire it to be that way, in case you're asking why. All right, so same thing we had here. By now, we should be used to some of this. So we use collinear, that's on the same line, that's what it means. We've gotten that out, right? So the same thing, we'll close up this loop. So I don't get to interfere with the PCB itself. Sorry, just right click, repeat the line. And you could just use your constraint to get it on track when you're on track. So this tool I've been using called horizontal vertical is a tricky one. And sometimes it could give you the undesired result. So this is how it works. It orients the geometry to the closest orientation. So if you saw when I draw this line, it was a little slanted this way. So it's called vertical horizontal. So once you select, now it is easier and faster and shorter for it to keep this line straight than for it to bend it. That's make this line a horizontal line. That is why it automatically corrected it to horizontal line, to vertical line for me. But if I had drawn the line, maybe something like this, right? Then do this. Can we see what's happening there? So it's not magic. It's just that's how it works to the closest possible orientation. So you take notes. So you don't think it's not actually a vertical tool or a horizontal tool. It does both. Right? If you actually want something to go maybe in a specific direction or something, you probably might want to leverage perpendicular, parallel, and some other ones like that. Okay, having said that, we just go over to extrude. I'll pick this up. And just to avoid confusion, let me turn this one back on so I can see what's happening there. Pull it out. Same thing, constraint. We'll call it what, FDM. Sorry. Click on OK. We have not done one thing. We are supposed to drill the hole first, rather. So let's redo, edit that. Cancel a first selection. Use this one to drill the hole first of all. Right. Option will be cut. Consistency, we say minor shell. Right. Click on OK. So go back, another one to port 4, naming convention, very important. So PORT 4. Then we can turn port 4 back on because we are still interested in the sketch. The fusion thought we are done. Right, so you just put it out. Then you can do your shell. Sorry, FDM. And we are good to go. So I can turn this off. So we have been able to create this, create the port, create the threading, create the extension. So somehow we are good to go with the bottom enclosure. So we'll quickly run to the top enclosure. But before I run to the top enclosure, I think I will give room for questions, please. So Tolu, you could help me look out for that.
All right, so far so good. We've been able to cover a significant milestone in this tutorial. I believe that Mr. Eduki mentioned yesterday that there were questions, so this is the time for us to take those questions. Let's have them now posted on the chat box. Is Mr. Eduki there?
Come. Stay. I'm speaking to you. Speak.
After excluding, how do you
Not
cut
hearing you. Speak to the radio.
Please, can you be audible? Be loud enough. Come closer to the microphone.
please, how do you cut the O? After
Is that the
excluding,
hold on, please, hold on. How many people have questions, first of all, before we know how many are going to? How many people are there that ask questions?
Just one for now. So go ahead.
Okay, please go ahead then.
after excluding, how do you cut the O?
Oh.
O.
After extruding, how do you cut the hole?
Yes. For the pot.
Okay. Mr. Fanime, can you please
Because now
revert to
All right.
just take it back a timeline so that you can see what happened?
All right, thank you. Thank you for the question. The one who asked, I didn't get your name. You didn't tell us your name, but that's fine. All right, so that is the beauty of Fusion. Timelines is the beauty of Fusion. That's one of the reasons why we are sent the file, because if you're able to even maneuver your timeline, you will understand every single thing I did yesterday. So, like the question you asked, that would be let's use maybe the last thing I did. So that would be the events that occurred before we had a sketch, right? So this is what we did. After having the sketch, we now did this extrude, and this is what I believe you're asking how I got the row. So all you need to do is to just right click on this, edit, and you will see you can see the red symbol there. It's because now our extrude, remember this is extrude is a very powerful tool on Fusion, very, very powerful. Is the operation now is set to cut, so that is why it's cutting through the material. If I say join, see what happens there is sealed, right? If I say it's going to be a new an intercept, look at what happens. The entire body is gone. The intersection is remaining, right? New body, it will still be there, but it will be a separate body, right? So I did a cut. That's why we had that. Another thing I also have to point out, since you asked, is also for the Fusion tool, we have been doing an extrude, a solid extrude, where we have a region. Are we together? And you now have to pick it up and all of that. So I still need to let you know that you could also use this extrude tool to perform what is called a thin extrude. So like you have just a line, it doesn't have any loop, doesn't have any, it's not enclosed. You could still use extrude to achieve what you're looking for by switching to this little guy you're seeing here. It's called thin extrude, right? So I won't do that, but you just go ahead. I've mentioned this, you can go and play with it and see how it works. So thank you so much. I don't know if there's any other one.
So just one more question and then we'll move ahead.
Okay, good morning. My name is Inchedo. Yeah, so I was wondering, before you started the whole design, you put all the, what do you call it? The user parameters. Did you get them from somewhere to upload every single one you needed? Or how did you know every single
All right. So
distance?
sorry, let me get the name again. You said your
My name is Inchedo.
Uchedo. Okay, thank you.
Sorry,
Thank you for your
Mr.
question.
Funimi,
Okay. Right.
before you answer our question, let me interrupt you a little bit.
Okay.
I'm
all
going
right.
through the names here, and I'm not seeing Uchedo on the list of names that were submitted. Have you submitted your email? Do you have Autodesk Vision registered?
Yes, it's Nchedo Chukwu.
It's N-N-E-N-C-E.
Okay.
N-C-H-E, right?
Yes.
N-C-H-E.
Okay,
It's
okay.
not
I found it. I found it. I've seen it.
Okay.
All right, go ahead. Thank you.
Okay, but please, you
Okay.
understand my question?
Yes, I do. Yes, I do. So this is what happened. I wanted to ask you if you were with us yesterday. I wanted to start there.
Yes, I was with you. You uploaded the user parameters, but you didn't explain exactly why you used all the figures you used for each parameter and how you were able to know you are going to use every single feature here before you started designing. Because during your design, you used the different um,
Parameters.
distances for different things, right?
Okay.
But how did you know
Okay.
you are going to use all these single before even designing?
All right. So thank you so much. First of all, I think you came in late because I did, we actually dwelled more on parameters with for a long time before even going into the design. If so, probably when you go to the recording, you will see what I mean. But let me just answer your question and for the purpose of maybe some other persons that join us. After you have done maybe your background work, like the first one we did as a presentation, the requirements, specification, and all of that. Now you still have to sit down. Remember when I talked about design constraint? That is the one now that really concerns. That's the one now that you're pulling out to use as maybe the technical specialist, the application engineer, the design engineer, all of that. That's what you're going to be. That's what's going to be directly a constraint for you when going about the design. So it means that you have to sit down and also do a thought, like you have to have a thought process. What we call workflow. And my colleague explained that on I think the first day. Is very, very critical. You have to even know what you want to do and how to go about it. You might not have all the details, definitely, but you should have, okay, I'm trying to achieve this, and this is probably what we need to achieve that. So for the parameters itself, we did it together in class here, where I was inspecting the PCB height, the PCB thickness, distance from PCB to this, all of that. We did that together. So when you check the recording, just for the purpose of the class, so we don't take too much time on it. When you check the recording, you see every single one of it. So for instance, you see me say shell, right? You see me say fillet, you see me say chamfer, you see me say bus height. All of that were design parameters that we used either as a result of we have measured something and then we brought the value we measured and put it in here in the parameter section and named it, right? Or some of them, like the one you're seeing FDM, we are getting it from a rule. You understand? It might not be the specific number, but it might be the range within a rule that allows you to do a certain thing. We are going to get to the FDM aspect, right? Later after this technical session, right? So the other ones, there are some here that will still have, is still within your own, you're the one now to see if it's good or not. You still have that degree of freedom, whether I should use 5 or 6. Those are the ones like fillet, chamfer, because here remember you're also going to try to balance functionality and maybe aesthetics, for instance. So maybe you're designing is not yet very clear to you, like it's when it is finished, you say it's finished. As long as it's not finished, it means you could still change something. Or the client might say, I don't like this, it's too round, you understand? Make it a little sharp, something funny, you understand? So when you start saying things like that's where you will now start saying, okay, maybe the fillet should not be 4. Maybe we should try using 8, or maybe we should try using 2. These ones now are not casted. They are not as if it must always be, but there is a range. It should not go below. You understand? Depending on what you are working on. So I don't know if I've been able to answer your question.
Okay. Okay, but now the bus height, right? The bus height is the distance between the PCB and the lower part, right? The bus height is 12. So if I'm to reduce the bus height to something like 10, will it make any difference, or is 12 millimeter a fixed?
No, it's not fixed. How we even got bus height was a direct measurement from, like you said, from the bottom of the internal enclosure to under the PCB. So already reducing the number means you're suspending your PCB on the air. And I did explain that reduction is possible and can be done depending on the approach you're using. There's also the business side of things. So are you planning to bring in maybe what you call insulators? You know, if you look at most of these electrical components, before they put the screw, you see something, maybe plastic or made out of composite or something. So if there's going to be an insulator, definitely your bus height, yes, is 12 that you wish to use. But during your implementation in the software, that's when you're doing extrude, you could say 12, you now do minus, as you're subtracting, that gap now is where the foreign body, maybe let me just use maybe a washer, for instance, would be inserted. So it's not as if it's always going to be 12 or 11. We measured it, we had 12, and then now we now said, okay, let's have a little clearance. Do you understand? Well, I believe even the one we have in our current design is not exactly 12. It's a little lower than 12. You understand? I hope that's clear.
Okay, thank you.
You're welcome. Okay, Sammy?
All right, thanks for the questions. I think we can go on with the remaining part of this presentation.
All right, thank you very much. Okay, so you could still, if you still have more questions, just be, loading them and sending them across for the next round of questions. So what we could simply do now, we could decide to maybe insert these screws already, or we could also decide to maybe probably bring it at the end of the end stage of the design. One of the reasons why any of them could still work is because since they are separated, we have top components and bottom components. So it could also be like, okay, if you're done with the matter that concerns the bottom, you could just make sure you cross all the T's, put the nuts and all of that, and then you head on to top enclosure. All these ones are, just depending on your own how probably you feel would be best for you. You understand? So one thing I would like to show us is this, just a quick one. Because there are times when you're designing, this is just a kind of a circuit and an enclosure that is used for teaching purpose. So we don't want to make it very complex. But there are times where you have this timeline populated from this point to this point and counting like maybe 2 times. You have to roll down twice. So when it starts getting that way, one of the ways to take care of it is, having your components where you begin to activate and deactivate. So for instance, if I should activate bottom component, and maybe there's a lot of things on my timeline, I can move over to the gear icon and say hide all inactive features. So you could see that my timeline just became small. What is simply saying that all these things here are the things that concern the active component, which is what bottom. So anything that is on the timeline but does not concern bottom is removed, right? So you have to, it's very, very important. If you know how to play with your timeline, it makes life a little easier. I could also want to turn on my color components swatch. And this is what it does. By mere looking at my timeline, look, I see a yellow line here. So it means that I know that everything from this point to this point is what was used in the creation of this member, this component. You could see the yellow line there, right? You can also see the yellow line here. So these are some other things they add to make light a little bit easier. We also have this one called display components colors, right? So I would return that back to no, we don't have confusion, just keep everything as it was. But this is one thing you might want to do. This one I like to use most times is, since this guy, the sketch, the extrude, another extrude, another sketch, you can see what is highlighting as I'm moving, are all we are all created, or they are all under one category of what I am trying to achieve. Let me even start from here. This one we did yesterday. You stopped here, this. So what can you do? You could just go over, hold shift on your keyboard and move to this part. That's if you want to select all. But if you're not selecting all, you wouldn't use shift, because shift will take, as you hold down the shift, it takes everything within that a range that you've selected. So I just hold shift, selected this one, and left to this end and selected. So what do? I right click and say create a group. So can you see what happened to my timeline? Is that this is one of another best practice to both make your work well detailed, helps you for be able to make your edits easy, right? So once you just come to this point, you could just open it up, and everything that that's happening here is port. That's all that's happening here. So I just had to give you that like a bonus, right? Okay, so now we are moving on to the top member. So we are done with bottom enclosure. So I will activate top enclosure. Click on my radio button It's not visible because the eye is, the visibility is turned off. So I'll turn it on now, then turn off what? Bottom. Right. Can we see what's happening there? Okay. Let me just, so we could just have a visual, look of what's happening. Just turn it. Okay. So now this is what we are going to do. We know we are going to use, remember part of the specification. We did say that we need a simple but durable, strong, and effective way of locking the top as the components, assembly, and all of that. So since we had decided to go with snap fit as our as the future we are going to incorporate on the design, so we can do this. Turn back on that bottom enclosure. Turn off the. Okay, turn back on the bottom enclosure. Turn on the eye. And then you could do this. You could do a direct sketch on the wall, right? So I'll just orient this or zoom in rather, right click and say create a sketch there. At this moment, I don't need PCB, so I can just turn it off so we can see what's happening clearly, right? So this is what I would do. P for projection. Right? I just need the outside of this enclosure, the outer wall. So I'll pick this up. Sorry, there's a mistake there. So I'll right click and click again to deselect. Right, so we have that. So I'll click on OK. Then do an offset. So I'll be offsetting this guy. For consistency, what do I call it? Shell. Because we know the magnitude of shell by now. Right? So I'll click on OK. So we have a line around our wall, right? Zoom in so you can see what I'm saying. We have a line around our wall in this manner. This is what I'm going to do with it. I'll come over to my extrude because this is already a loop, right? So I'll come over to my extrude. Okay, for correct practices, you just click on finish sketch, go over to this guy, give it a name as well. We could call it okay, so this will be our snap. All right, so all we need to do, what I just did, I'm not doing it again, but just to, for the purpose of, I just created a line around our base. I did an offset, and the offset has a magnitude. For consistency, I use shell. So exactly the same thickness as the wall, right? And we'll see why I'm doing that. I called it snap, right? So all I need to do now is just to finish up my sketch and apply an extrude. So what I'm basically doing now in my head is, okay, how are we going to lock the top and the bottom? I think at this point in time, it's better we, table that matter before we proceed to do other complex things on the top and then find out that we cannot lock it with the bottom, right? It makes sense. So we just put this up. So already you could start picturing how, or you could start having that picture of what this will look like, right? It has an extension that will allow what your top to what sits in. Can we see what's happening there? This is the top. It's grayed out because it's not active, but you can see how it goes in, right? And then inside here, we can now what entrap the the top enclosure, as we can now lock it, right? So I will show you one little thing here. Let me stand this up. So this is what it looks like, and then I will say, okay. So I'll say 6 mm. Another thing you should also have in mind is, don't forget you're going to be printing it out. So you don't want to also use something that's going to waste a lot of material during printing, right? Meanwhile, something smaller would have also done the same work, right? Okay, because you'll be wondering, okay, why is he also doing this? Why is he doing that? So I'll turn off the top now. I just want to show something. I'm doing this on purpose. So I'll click this to be joined and then click on OK. Now, someone might think that this is very okay, and you just take it and go and print and everything is fine. No, it's not. So when we do a section analysis, this is what is happening inside this guy. That is why you have to be also very careful most times. See this one, this is already a failure. Like it's failing before it even starts, being functional. I don't know if you've seen all those kind of stuff that when you just place your hand there and it's as if it was just waiting for you to be pulled out. You understand? That's exactly what it is. Because the only thing holding what you have just created and what was existing is a line. It's just this line. And even on the printer, the printing will also show you that there's something happening there, which is not what. When you're having your shell, maybe your infill and all of that's running around, you will see something going on wrong there. So like I said, it looked very good when we did it without the section, but it's a failure, right? Already before you start. So this is how we correct this. What do? I simply move in and say, okay, extrude is very powerful. So let's make these two sides. I didn't say symmetrical, but you could also use that if you wish, right? But since I'm trying to be a little consistent, I can pull this one down. As this one going here, just to be sure. Look at the other distance. It's called side 2 moving. So I wanted to know which one of them is, the arrow going down. So side 2 seems to be changing its value. So that's the guy handling what is happening downwards. So if I should set 2, for instance, or 3, it's going down, right? So what I will simply do is to make this equal to a shell. And I still click my join, right? Then when you do this now, and you see what's happening? So this will now look as if you originally did the design and then shell, because this is how exactly shell works. Remember when you say shell and it's a thickness of this. So after excavating and removing the material, there is a uniformity. And that's one thing that you don't play, especially when you're dealing with injection molding and related kinds of design. You understand? So this is also something you could leverage for. Yes, it's going to be 3D printed, but it's also very, very useful that you have this uniform wall thickness, except places like this, which is understood. Oh, there has to be a thread. First of a bolt, what's it called, screw going down. Already the screw size is already big. The boss around it that has to accommodate the screw, which by as a rule of thumb should be at least 2 times of the screw. You understand? And then we also did this reinforcement. So yes, this is understood. What's happening here is understood, but the one we had up there was a failure. So I believe we have been able to see what I was trying to just show us on that particular. So I'll just return this back, and so we have our bottom enclosure looking very fine. One more thing remaining is how are we going to lock it? How are we going to lock it? Now, if this comes in here, let me show you something. If this comes in here, so I will do a quick section. This is what's happening. Funny enough, this will still lock, right? It will still lock. But this would be a kind of temporal lock. One of the reasons why it will lock is because the friction that will be taking place here is very high. You understand? This is you putting a 2 mm pin in a 2 mm hole. If you're conversant with interference, clearance, allowance, and all of that, you understand what I'm saying, right? So this is going to still lock, but you wouldn't want to go this route because of the nature of what you're designing. Except it's something you just want to put in, remove, maybe like what do I call it now? I could say maybe a plate, plastic, something that you don't really want. You just want to remove anytime you want and all of that. Then that's fine. You're already done. But we know that this is going to be where it's going to be used. It has to be a little, at least it should have some form of a tight, enclosure. Like it should be firmly gripped, even if it's not a permanent kind of grip, right? Because even like if you're implementing a snap fit, there are kinds and there are use cases. There are permanent snap fits that once you just put the two and lock it together, that is the end. The only time you remove it is you damaging, like when you try to remove it, you damage the fit. So it's done with something that the manufacturer or the designer is already having in mind that there's nothing, you don't have any relationship with what's happening inside there. So if you spoil, maybe just throw it away or something, you don't need to open it up. You will see that happening with some of your chargers. There are some chargers that you won't really see how to. In fact, for the only way for you to open that charger is for you to destroy that charger, like probably destroy the case, right? So that also happens. These are all intentions. They is not by mistake. That's what they want to achieve. Do you understand? Sometimes you could even have something that is even that this will be more like interference now. Having this even higher than where it's going to be contained. So it's going to be forced in with pressure. And probably they will even attach, they will even use some adhesive, maybe a permanent glue. So if you wonder how did they lock this in, how did they lock this in, they don't even want you to open it in the first place, right? But our own, we want to do a semi. So it's still going to be strong, not too free, but you can still open in case you just wanted to check something, right? So I have to explain this so you see, you understand why we are doing what we're doing, the next step we want to do. So I just turn back that on, turn this off, turn back my section, and then I would do a little movement, but it's my plane. So I don't want to use these walls now because it's getting a little complex. The wall is no longer just an ordinary plane. It has some future. So I don't want a situation where maybe tomorrow we say, oh, let's close up this port. Already that changes the identity of where the plane was brought in. You understand? That's a little bit advanced anyway. But because of these many things we are now having here, I wouldn't want to draw directly on this place, right? So this is what I will do. I will pick up the offset plane and just offset it and push it in, right? And then continue what I want to do. So we could just move this in by, say, 25. That's okay. So we just click to accept. Just click to accept. And then one thing with the plane is you can play around with it. You can pull it up, you can drag it up, and so on and so forth. But you cannot do this with the origin planes. So those ones that came on your when you started the design, the ones we have under these parts, you can't do this. But these ones they give you that degree of freedom. Because sometimes you could use plane to do design without even using what sketches, like much sketches. The plane itself will act as the intersection and all of that. So that's why you're allowed to do things like this when you're bringing in a plane, because it could act like your knife, it could act like anything. Okay, so now we have this plane. We simply sketch on this plane. Right click and create a sketch. So like I said, it's not going to be a permanent lock. If not, I would have started looking at using a cantilever snap fit with very tight tolerance. But we are not going that route because that will also require us to spend some time with some explaining. So we'll just use something that is, still something that still works, but it's easier to get. So we'll just say, I'm trying to locate that plane. So I'll just give you the name. This sketch we just created now, we call it the snap fit. Right. So you can call it a semi-permanent. So it's not fit. And then I go over to the construction. I could just copy this name and come over here, drop it, right? That's fine. So this is where we want to draw on now. If you notice, you can see what's happening there. So what do I do to get this wall? Well, I need to know where this wall is passing through this. That's where the wall and the plane have intersection. So what do? I just go over, I probably have to use my plane. Now, at this point, you could use the intersect because there is an intersection between the wall and the plane. So if you move over to the intersection, you can see what's happening there, right? So I'm using projection that we have been using, but this is a different one. This is not the initial one, but the one that we project the intersection between maybe a plane and the geometry and so on and so forth. There are many of them, so you could just play around with it. We have 3D projection, surface curve, and all of that. So we are using intersection, and you've seen why I used it. I just explained that there's already this meeting point between these two, and all I needed was just here. So this means this gives me exactly what I'm looking for, right? So I just click on OK. The plane could go home for now. So what do? Do a sketch. Pick up a line. Turn on my palette. Move on. Just do a rough drawing. Okay, let me keep this on this view so you can see what's happening. I'm actually drawing this way. Remember how our plane is oriented, right? Let me even slide so you see this is how we are going. This is how we are moving from that guy outward, right? So you move out, then you just do an enclosure directly there. Okay, so you could use your default dimension to now keep things uniform, right? Pull this out. And then you give that a number. So you should know that all the way from this top to this bottom is what? Is where the locking is happening. Aside this part, you have entered the bottom enclosure. Beyond this part, you're going to the top. It's not. Sorry, in fact, from this part, you're going to the bottom. From this same part, you're going to the top. So that means this is everything happening here is what is where you can actually activate your lock. So I will just call this. So escape as a mistake. I wanted to say 2 mm. Okay. Then dimension aligned. See how I'm moving. I'm not moving this part. So this is another one. Moving this way to actually know the extent of that guy there. Right? We are together. So I was just say 1.2. They look very funny, but you will be amazed at how that little bulge out there can lock your system. And it's as if you can't pull it out. Very tiny, but powerful, depending on the angles you're placing them, the points of entry, angle of entry, and the angle of exit. That's where the objects will be pulled out from. I will see explain further anyway. So I could decide, let this be 45. So if I'm moving by this way, that would be 135, I guess, 135. Right, are we good? And we have that. So that little member there is what we want to use to play the trick of locking the components. Like I said, semi-permanent. It's going to be strong because these are very bold movements, having this very sharp this way. You understand? If I don't want to have that form of, what's it called? Extension, I will probably want to tilt this way. So I'll pick up a line here and decide to move this way. So it will also have a sliding at this end, but I want it to be kind of permanent, but not totally permanent. So that's why I'm making this bold move here, right? And then the number 1.2, if you could imagine, if you have your ruler by your side, you know that 1.2 mm is very tiny, it's quite small, but it still does the work. Okay, so what we are going to do next, I will turn this one off, slice out, then home, zoom in. So this is what it looks like. All right, so we use this little guy we've just created, finish up that sketch, go back to extrude, right? Pull it together. So I think at this point, just once I'm done with this extrude, I'll probably pause and take questions so that I will know that we are actually following along. I could just call this minus 10 millimeters. So that's like a 1 cm. Thank you. Please let's help ourselves and help Sammy as well. Once he asks a question, we could try to be snappy a bit. So we don't have much time. It's almost 12 already. I will still have to go for a break and still be back for other things. But let's all help ourselves, right? Okay, so thank you. Just let me put this as minus 20. So we don't have to have a multiple of them, right? So basically now you have one. You do what? You duplicate, right? So in order to duplicate that, I'll use a pattern tool on the crate because it's also creating something, like it's trying to generate something that probably does not exist. That's why it's grouped under this part. So I talked about futures, bodies, and all of that. So now automatically you can see the object type says body. So I can actually pattern this body to have multiple bodies. And I can select maybe the whole here because I am on body. That's why you need to understand that these things you're applying on your timeline, the extrude, all of these are called what? Futures. And the futures will combine themselves to give you what? The body or the components and so on and so forth. Like, it keeps on going. So for instance, you could do this and then say this. Look at what happens now. I have multiple bodies, right? But this is not what we're trying to do. This is not what we're trying to achieve. We're actually trying to achieve a duplication of what? Just this one. So you don't go and start stressing why is it not working. It's just because you need to switch this to what? If it's a face you want to pattern, you switch to the face. If it's a component you want to pattern, you switch to component. If it's a future, like what we are doing now, I've switched to future. So now I can select this guy, but To be on the safe side, I will not go selecting it directly. Rather, I will go select the thing that I use in creating it so that I can have everything that has to do with it, right? Instead of picking one by one. So how did we get that guy? Let's see, select object. We did an extrude. So I'm selecting extrude. I believe we've gotten that. So how do you want to move? Now, if I move in this direction, this guy will only be going forward and backward. Can you see what's happening? Let me orient properly. Can you see what's happening there? And this is, of course, not what we want to achieve up and down. We want it to go around the object. So what does that mean? To go around this loop. So I have to now look for a separate. If it was circular, I will just pick up a circular pattern. But now it's not even circular. It's more like under the category of irregular. So it's curvy at this point, it's straight at that point, and curvy at this other point. So when you start having those kind of stuff, you switch to what? The third one called pattern on a path, right? So I've moved to pattern on a path. We're moving a little bit. Then I will select the path. Where's the path? So I want it to move around this, part. So I'll pick up this. So that's my path. And so how it does is it starts from 0 and ends in 1, right? Or like your thing you do in mathematics, right? 0, zeros and 1. So first of all, how many do I want, right? So you could put this out first. Quantity, how many do I want? Let's say I want, let's see, 1, 2, 3, 4, 5, 6, 7, 8. We want 8 of them. Are we good? Right? But it's still going somehow. It's not giving me what I want. So what do I do? Orientation. Please be what? Follow the path direction. So it's still doing loop, but it's moving how he likes. Do you understand? It's following what? And like, remember it was straight. So it's trying to maintain that straightness. That's what we mean by identical. But now we don't want it to be identical. We want it to be, if this place is facing this side, you face that side too. I don't know if you're getting what I'm saying. So with that one, you have to also switch to path direction. This is very important too. It could just make your life, interesting at the same time, very frustrating. So I've switched 2 things here, very important, that made me to be able to do what I'm doing now. And then you just, okay. Let me see. So you could say, how you could get an exact number will be, you have to measure your loop and know the distance around it. I think perimeter, something like that is called. And then you now know how to separate. There will be some, mathematical stuff around it. You now know how to now do, okay, what will be the distribution, what's it called, the spacing around them. But we are not going that route for the purpose of the class. So what we just simply do is what? We'll align this. You could do a visual, like using your eyes to see what's happening. We have 1, 2, 3, we have 4. Let's see what's happening on the other side. We have 5, we have 6. All right. So this is exactly what we wanted to achieve. So what I will just do now to be more specific. So I will not be having this 4, 10, 4, 10, 9 something that we are seeing on the parameter section. Right. So I could just come over to this point. Let's see. 429. So I'm more defined now. I will inspect that again to see that it's closely related as I want it to be. Yes, they are. Yes, they are. Yes, they are, right? So you're done with that, you will click on OK to accept that. So can you see what's happening? You see this on your plastics, but most time you will not notice. If you take your time, you will see most of them. There is no magic there. There's always a way to join two members. Is it that they are using cantilevers, they are using protrusions, they are using so many ways, but something somewhere is making it possible for them to be what's clipped together, right? And so you don't want to be caught off guard. You need to know what those things are, how to use them, when to use them. Okay, so now we've gotten this. We think it's time to go back to top, because now we've gotten the holder, the parts are more like we call it the nose, right? Now, which is more like the one that is sending, and the one that will be the receiver, that's on the top, right? We just have a normal cutout, right? So next thing we are going to do, we will activate top. Top is active now. We could make do with, okay. Top is active and visible now. So can you see what already, you can already picture what's happening in here. But now, if you notice, we have not drilled the hole yet on the top to accommodate this. It means that this will be pushing that top button away. It will not allow it to enter. And if you ask me why I slanted this, I expected someone to ask that when we ask for question. The reason for slanting this is because when it comes, it has to first of all move some distance away, right? And now the hole, you will see we are going to create that hole. The hole on the top, once it moves away at some distance, this tip will now lock with the hole. And then it will not allow that thing to push what back up. The only way you can push it back up is what? By making a manual, like you have to press hard on this part. You press on this, see this way, how my arrow is, I'm pushing my arrow. That's from this part to this part. And then let me also turn it this other way. From this part to this part. So you could use maybe your hand or something to press it in. And that is the only way to be able to what? Lose away from that grip of that guy that is pointed. So I will also show us that again once we drill the hole, so that it not be too much imaginations. So we just to simply drill the hole. I don't need to go and start creating much of those sketches anymore. One thing I could just do is, before even heading to that part, I could just do a combined cut operation. So this is what you, when you hear a Boolean operation, subtraction, addition of shapes, to get one. You can see from the symbol, it's already showing you that something is fused together. That's exactly what it's going to do. But this time around, we'll play around with the option. So we just say the bottom. Okay, sorry. Target body will be the top, and the tool, as this second one, you can see two options here combined. Tool body will be the bottom, right? Now, what it means is that the tool is the one that will do the cutting, while the target body is the one that will receive the cutting. So more like, the tool, maybe the bottom will be the knife, and the one on the top is the one that will receive whatever you're trying to cut out from, right? So now it's looking fused because it's on joint. So I'll change it to what cut. You can see it's highlighting red. So every member of that part that is red is serving as a tool. So anything that enters it, even if it's the PCB now, it will destroy it, like it will want to cut it off, right? That's why I turned off the PCB while doing this operation. So you could now do one more thing, because if you should click on OK, it will still cut, but our button will disappear, it will go, right? But I don't want the button to go away. I don't want the tool I'm using to cut the top to disappear, because I still need the tool itself. So what do? That's why I will now say keep component. I hope this is clear. So keep the component. I've selected keep component. You now click on OK. So it does the cutting. You can turn this off now. So when you zoom in, you see what's happening there, right? You see what's happening there. You see what's happening there, right? I don't know if I should take some questions here. I hope this is clear. Are we good? Hello, Mr. Sam. Can I proceed? Are we good with what I've just done?
Sorry, can you please repeat the cutting section, please?
The combined cut operation.
The cutting operation.
Okay, so just right click. This is what I did before. This is how it was. So I said, cancel. So they were like this. So I said, the target body is the body that you want to perform the operation on, right? So this is the target body. I want to perform a cutting on my top. So I collect. Now, tool body is the one that will do the cutting. He's the actual knife, right? So tool, I will say bottom. Now, why am I using bottom as my tool? If you notice the groove, the extension, not the groove now, rather the nose itself, right? The opposite of the groove we're talking about. This extension we're having here, let me turn off the body just quick, is on the base. So that means for me, because I will not be able to even get them separately, like going to select them and say, oh, just this place, do the cutting. No. You understand? So that's why I was selecting the body called bottom enclosure to serve as our cutting tool. No problem. Anywhere that there is no, it doesn't destroy the material. You see, it's just that anywhere there is a contact between body 1 and body 2, that's the tool and the target, right? The tool and the target. Anywhere there is a connection between both of them, something will happen. Now, what will happen is this one you're seeing operations. Do I want to join it? No. Do I want to have an intersection? No. I want to do what? I want to do a cutting, right? To cut, to drill, to make that impression, right? That's the right word now, on the top enclosure. But I also pointed out that if you should click OK, but some enclosure will disappear instantly because you're basically saying it is just a tool. After cutting, we don't have need for you. But we all know that we have spent almost how many days trying to get the bottom enclosure. So it's definitely useful. Like, it's part of the system. We cannot make away with it. So that's why we have to select keep the tool. Right? That was the whole thing I just did. So when I clicked on OK, it did its computation. If you should off this guy, you will now see that impression from the extension on the bottom on this face. I believe you understand what I'm saying now. All right. So one more thing I'm going to also do is this. Just to be on the safe side, because don't forget you're also trying to print this out. And when we get there, we also describe when we're back from our break. And there are possibilities that during printing, some things might not really come out the way you want it to be, and there are reasons for that anyway. So we will not allow this to just rest here, right? I'm trying to explain what we want to do in the next move. We'll not allow this to just rest here. But just before I do that next move, I taught us how to group. So let's just quickly group all everything here, because we use it to create something with the bottom. We can just simply group. That one is gone, right? See how our timeline is looking. So we'll just come over to this point. We start with this face. So right click on that face and do a, okay, let me start. Excuse me, let me do from the inside. Let me do that from the inside. Let's see. It's better to start from the outside. So right click on this face. I'll create a sketch on it. And what will I simply do? I just come over. It's already there for me. I don't need to do much work. The combined cut operation has already done this impression for me. So what I'm just trying to do now is to play safe so that when I print, I still achieve my aim, right? So I'll come over to this place and do this. Are we good? So I'll just do this by what is called FDM clearance. I hope this is making some sense to us. It's going in, so I'll just do flip. See that guy now? Okay, it's quite easy, right? Same thing. Come over to this side. I'm sorry, not sketch, fillet, offset rather. Same thing. What's his name? Clearance. Trying to be a little bit snappy. So we can pause a little for a while. So we have that. So I can even perform. Okay, let's just finish with the sketching before we go ahead to perform the cutting. Finish. So the same thing on this part, right click, okay. Same thing, you move in, you pick on your sketch, you just do an offset. What's the number? You say clearance. You put it in there, you flip, you click on OK. I hope this is making some sense. I'm trying to be a little bit fast since there are many. Same thing in this part, you zoom in, you pick that guy up, you do clearance as your magnitude of the offset, you flip so that it goes the opposite direction. You're good. Finish up that sketch. Right? Same thing on this part. Right click, remove in, sketch, offset rather. Value, you say clearance. Sorry, there's a mistake on my, no, okay, works now. Clearance, you click on OK. Move to this other part, same thing, offset, you move in. We call this what? Clearance. Pick that up. I believe that's all. Any other one? Okay, one more, sorry. Finish up the sketch. Same thing. I click. Create sketch. Move in. offset. Okay, we could see a little challenge we're having there because there's a discontinuity on the shape right here. Okay, so we'll do a little one here with, let's get this first one out first. We'll now do clearance and flip. Okay, so when we're about to do this one, what we could basically do, excuse me, is to do the same offset, but you remove the change selection, right? I'm pulling it so we can see. See this guy here, chain. We don't want it to be chain no more. So we can now do separate. Are we good? So it's click on this point, click on this point. That does not allow us, no problem. We still do what? Value clearance. I'm sorry, clearance offset. Click. What do I do next? Repeat operation. And then what you notice at that point is actually slanted. So it means that it is not on the same face. Are we good? That is why I'm unable to pick it up. This is at the point where you have a transition, a fillet from a flat face to a round transition. So this is where you do what? Simply call it in with your projection. So just project that guy to your current face. Click on OK. Do the same thing we have been doing since. You see it's picking up now. All right. I'm sorry. Or you could even avoid trying to, you could just draw the line yourself and join it up, right? Anyone that you feel is okay, but let me just use what I've been using. Let's call it clearance and then click on OK. It's not straight. So you know what? We would do a drawing, get it out directly. So let's put this in, you snap up there, get that done. Move in, you could click on OK. Start from this point, you snap up there, you move down, right? And then now you pick up your line. Because it's basically just for cutting. We're trying to cut something, and that's why we don't need to worry much about it. Understand? So now this one is trying to move away. I would say I don't want that effect. We could use a collinear effect on it. So that is it. We're going to achieve that place now. So you simply finish up your sketch. We have 1, 2, 3, 4, 5. I want to 4 sketches, right? Handling all of that. And then I think I'll wait for questions later. I'm done doing this, but I think there should be a question rather. So I will now do an extrude by cut operation. Moving, pick up, right? Just pick it up, pick it up, pick it up, pick it up. You could just do it's a basic cutting operation. We are just trying to make a hole happen there, right? And we have added clearance. So you could just this one you could decide to tie it to the wall, or you could just decide to give it some value, or you could decide to say, well, you might not want to use all, because when you say all, it will want to cut even out to this part, and it's not as if it's purely symmetrical. So it could mess up things for you. So for this one, I could just permit you to just do something like this. You cut, clip and drop. And let's see if it has given us what we're looking for. Yeah, so this is what we're looking for, right? So you just repeat the same process for all. Please, if you have questions, you can start gathering it now. But once I'm done with what I'm doing, this very one, I want to see if there are some questions. So don't waste much time. So just move that in. Or if you don't want to use this, you could let me also show us what we could do. You could try using two objects, right? So when you just come, you click on this face and it will give you what you're looking for, right? That's that. Move over to the other end. If it was symmetric, I wouldn't have to do all of this, because I'll just do one and mirror it, but it's not. So these are part of the reasons why you also have to really do that liaising with your electrical design personnel to ensure that some things are in place. Or you yourself, the one design, you also ensure that you're trying to make some things symmetrical, right? It makes the work a little easier for you. So click on that. I don't know if there's anyone remaining. We've done 1, 2, 3, last but not the least. Extrude. I would have left this here, but first let me wait and see if we have some questions. Okay. So moving, same thing, we'll call it so object, right? Moving, select, and we are good to go. So I'll stop here and check if we have, do we understand what we have just done? Because from here, I think we are about maybe a few steps to get our enclosure ready.
Okay, sir.
All right,
I was
please,
wondering.
your name, please.
Okay, my name is Nchedo Chukwu.
All right,
Yeah.
go on.
Okay, so I was wondering, the bottom protrusion, right? The angle that you gave at that bottom protrusion. What if you want to make the protrusion a continuous rim around the top? How do you make it continuous instead of it to be segmented?
All right, thank you so much. That is a very good observation. It's a route we can also use. But that will also mean that on our top, you see this place here now. I'll answer you, but let me just show you something. You see it's segmented, so we're having this wall continuous segmentation, wall continuous. So if you're using that route, it already means that you're going to be having this separation all through for it to be able to lock up that divide. Like this will also be continuous to accommodate it from the female section now, right? Sorry, from the male section, this will be the female section. So now if you wanted to do that, let me go back. So let's see. All right. So we know we use an extrude to achieve this. Now, this extrude is very powerful, but of course, it's tailored to achieve very specific kinds of things, right? So extrude will not be your part. You won't use extrude to want to achieve that because it will not allow you to move around. You understand? I believe your question is, instead of having this here and stops, it should just move and continue, right? All this way down.
Yes.
Right? It works. It's even if I wanted to actually go about the design, like for maybe something I want to use, I like going that approach too because it kind of makes the work a little easier. You understand? But for you to achieve that, you won't use extrude. So this is where you want to leverage revolve. Who will what move? But now, even this revolve, you have to really play around with your axis and the plane. What's it called? Sorry, you're going to use your sweep rather. Sorry for my mistake. Sorry for that. You're going to use your sweep tool, right? So you can see how the sweep tool is. Let me see if I can even show us one. Let's see if I can show us one. So, okay. So you have your profile. That means I will have to roll back. Let me just roll back the one we did up to this point. I think this was the very first. Okay, not even this side. I think it was on the second grouping. Yeah, yes. So this is it. So let's come back all the way. So this was the guy. So my skill, sorry for that mix up, not revolve. You're going to use a sweep tool. You have to sweep it, right? So the same way you have it here. Oh, let me turn it on. It's gone. It's not fit. So you just come over, pick up your guy, sweep, and select loop, right? So parts, this is why it works now. Just the same way, remember how the circular pattern gave you room for parts selection. So you see what sweep is doing for you as well, right? So because you can select a part now, you can pick this as your part. Have you seen what's happening there? It's already come out even before me trying to, can you see?
Can you kind of repeat 30 seconds ago, the screen went blank for some seconds.
All right,
So
thank you very much. All right, thank you very much. So I was trying to say, first of all, sorry for, it wasn't not a It's not a revolve rather, but a sweep tool. I, mentioned something else while thinking of something else. So sweep will allow you to move, give you that degree of freedom, moving even in an irregular path. You understand? So this is also somehow qualified as irregular because we have straight paths, we have a bend. You understand? So it's not, the forgive my language, it's not staying in one place. You understand? All right. So what you basically have to do is you've selected your sweep tool just like you saw me do. You come over to path. It's quite easy. Where it will be difficult is when the path is also disjoint. And that's when you now have to really play around with it. You could see taper, twist, orientation, and so on and so forth. But this one is quite easy to get because there is no limitation. If you see, as I just selected the loop and selected the path, it has already done that around the object. So now if we should do your section analysis, the one that asks, I think Ducci, right? So if you do a section analysis, you see that the part is just going all around. So in fact, if I'm using in your own design, probably don't use my method. Use your own method. Use this other method, right? You still achieve that. So I believe I've answered the question. Over to you, Sam. Any other one?
I don't know.
Okay, thank you, sir.
Okay,
Then if
go
you
on.
want to make the protrusion symmetrical to ensure that it's at the same distance in the 4 direction.
Yeah, that's where I mentioned we didn't do you have to actually know this is a part now. So it has like a form of a perimeter distance around it. So you have to have that number first of all as you do your measurement. You understand? Then also it's just math. Also from year to year has a value. For instance, say 20, right? So how many of them are how are we going to position each of this, let me say 20, such that you're able to have it have the same distance all around. So if I wanted to do that, I won't even want to move with my pattern, having it all around. I will probably just do the first two and get it where I want, right? Once I get this and this where I want, then I will move over to using my mirror because that will be the best way to have it symmetrical. Right, once I have this first two with the distance I want it to be, maybe 45 away from each other, are we together? I will now come over and use a mirror tool. This is your mirror tool. But before you use that, you need a mirror plane. So let me just show you because it's important so that you don't go struggling. You just run over and say mid plane, right? So between this face and this face, give me a middle. Have you seen what's happening there? We have gotten the middle now. So you can just use that to mirror these two to this other side and it'll be very symmetrical. You repeat the same thing at this other part. I hope that's clear.
Yes, sir. Thank you.
You're welcome. Recording, so even if you miss something, you probably will still be able to get it there. I'm not discouraging you for asking the question. If you have, please do. So we have activated the top enclosure. We'll turn off this one. We have this. So basically, other things now remaining is just, I think it's one of those ones we had on our specification, or even two of them. First one was around the cooling, the natural convection, right? So I will just bring out PCB because we need PCB now. It's quite important to see the PCB. So I've turned it on. I will do, okay, let's see what's happening there, right? So I will do a sketch on this plane using my top plane since it's flat enough and just right click and create sketch on it, reorient the part. And then what do? I start projecting things from the PCB up to the top. So P for projection. You see what's happening there? You see all those little dots? That's how messy it could be when you're trying to do an overall kind of projection. And when one of them changes, you start seeing errors on your work. So that's why I always use the term, it's better to project only the things you need into your current sketch and leave the other ones for the time you will need them. So this is what I'm basically saying. Instead of picking this up, because we just do this, if you're lazy, you just select this and everything just project, just pick the one you want. Understand? But that will not be a professional way. So you just move in and pick just the circle. That's what we need. One. I will turn off the bottom, this guy for now, so we can really see what's happening. Then turn this one, right? Okay, so that's even a mistake. This is supposed to be where we have the screw. So we don't need, that's not the one we even want to project. We remove this, okay. cancel, and turn it back on. Turn it back off. Don't forget our sketch is still active on the top. We are still drawing on this face, although I've turned it off to see the bottom, to see through the PCB. Or you could still use your control, maybe control 4, control 5 to switch between views. Okay, so now this is the guy, the heat sink. And when you liaise with your electrical design personnel, you get to understand what some of the components are and how they work and why you need to do what you're doing. So for instance, this was mentioned to be a MOSFET, right? That needs to be cooled using the heat sink. Another MOSFET, another cooling, and a transformer that will probably also warm up, whether warm up or heat up, right, during operation. So 1, 2, 3 are like the regions where I will probably want my air to come in, right? So I will do just one. Our time is, we don't have much time. So I will do one. And please, these things I'm mentioning, there's one I mentioned yesterday about plastic, what's it called? Extension. I talked about the web. I said we are going to do the boss manually. You saw how we did it, but I asked you on your own, try implementing the boss using that extension. That is one of the reasons why you have been given those license. You have freedom to so many things that if you are to pay for them, you understand the implication, right? So you just use them and get to know how they work. So I'm showing you some, but I'm also asking you to go do another, right? So like this point now, where I will do an opening for this top, I will also want you to repeat this process under the PCB, under the enclosure. That's this other part on the bottom, right? So I won't do both of them. I'll do just one for the purpose of our time. Okay, to save our time because we will still have quite a lot to do. Back to what we are saying. So like I say, 1, 2, 3 is very important to us right now. And then there is another thing important to us. So let me finish sketch so we can really see the PCB very well. First of all, let me just finish the sketch. We'll come back to it. So activate the overall assembly. So now we can really see the PCB. Now, if you zoom in or zooming in, okay, so you will notice that there are some components on the board, right? Can you see this guy? Another D33, D28. Let's see if we have more. Another. That's it. They are just 3. So those are LEDs, right? Yeah, on your own, you might not probably know. Probably, especially if you're not, are you the electrical design person? But this is where most of these things will be communicated. You guys are discussing and you're knowing, okay, I'm doing this, I'm incorporating this, you have to do this, back and forth in a good way now, like in a positive way. So these are surface mounted, right? If you look at how it is, it's like directly on the board. I see what's happening there. So what we'll just do is a very simple one. And there are many ways to go about this, but we'll do a very simple one. So just take note of your positioning. I mentioned D33, D28, and this one here, the writing is closed, but this is the guy I'm referring to. So those are our LEDs, right? So just take note of their position. So I'll go back to top enclosure, activate top enclosure, and back to sketch mode, right click, edit the sketch. So we'll go back to what we were doing before. As good practice, what do? We just call this, we have not been following some of our good practice for a while because we are rushing. So look at all these sketches here. You know what we use them for, right? These were the sketches we use in opening up the, so we'll just call it cutouts. Out. All right. Sorry. Let's see. So, so this one. Control. Escape. Right. I don't know if you noticed what I just did. I did that on purpose. You see, all of them, they were actually about the same thing. So instead of renaming all, I don't know if you got that. So I'll just undo, right? I want to name all of these to be the same. So I will just right click here, 1, 2, 3, 4, and pin on 1. So once I name it cut out, for instance, everybody turns to cut out. It helps you in other things when you're having multiple things on your browser. So these were cut out, and this last one we just created is for top TOP LED. So I can just call it LED top. Okay, let's say LED and vents, because we also include the vents as well, LED and vents, right? So that's that. So what do? I will zoom in. Now, I don't want to go the route of trying to project any of these, what's it called, components to the wall, because if you already see how it's looking, right? It doesn't have that, it's not the kind where you really need to know the exact positioning. So what I can just do here is, okay, I know that my LED is here. So I just come here, I can pick a rectangle to just do a rough guy around it, right? That's it too. Just do a rough guy around it. Let's move to the second one. Do a rough guy, a rough rectangle around it. Up to the last one. A rough rectangle around it, right? I'm a little bit fast, bear with me. So what I will do next is, maybe I might want to position the rectangle a little, so that it's not, remember our sketch should not be having this kind of degree of freedom. So I could pick up this line, I want this line. So I just do P for projection. So I can project this edge of the PCB, right? Do that again. Edge of PCB, edge of PCB, edge of PCB. Oh, it's taking everything. All right, and click on OK. So what do I do next? Don't forget that everything we are doing here is actually on the top. They are on the top enclosure, but they are looking as if they are on the bottom, because we are trying to see what's happening there. So now just simply, so that we can actually also make it a little stable. So you could just provide value. Okay, you just call that 12.5 already, since it's already there. And then maybe dimension, you could say, sorry. I could just say 12.5. Right, another dimension from this, sorry, from this part to this wall, we just say 54. Right, and zoom in. So I'll do what? Use dimension 2 to get from this point, pull that out. Right, region 6. So if you want to be very, very more, even more accurate, you could play a little trick, maybe project this bulb. Okay, I'll do just one, I won't do for all. In case you wanted to be like, oh, only I want to get the exact point. And this is how you go about it. I won't do it for all, just for this one. So I've done a projection. I could project on this guy as the LED itself now. And I pick up a line 2 and do this snapping to get the midpoint, right? Just move across. You see that rectangle there? You see this rectangle that just came out? Look at it here, is a constraint. So it's telling you that you're at the middle of that line. So you pull this out all the way. You see, it's showing me 90 degrees, so it's very straight. I will just convert this to what? What do I convert it to? A construction line. How did I do that? I clicked on the line and I clicked on X on the keyboard. Or you just better still run to your 2 palettes. Everything is there. You just look at it here. You just click it to change the guide to what you're looking for. So if you wanted to have an exact, because someone will say, what if I wanted to have the exact place? So you can just forget about most of these things I've been doing here. Remove this one to self. See this other one self, you remove it as well. And just come here and apply symmetry. Right? Just say that this line and this line is symmetrical to this line. So that's how you get it right in the middle. So I will not do this for all. I just wanted to show you that it could be done. But for the other ones, I will just put normal dimensions, right? So let's put a value here. Let's say 5. Okay. So looking closely, we could see there's another component here. So we don't want to have that collision. So we probably have to reduce this. So what do you do? Another symmetry. Just pick up your line to make it symmetrical to this point, pull it out there. Right? Same thing, turn this construction, remove this one self that you have. Okay, all right. So you go back to your constraints, pick up your symmetrical, so that this side and this side should be symmetrical to this line. So let me remove this one first of all. Okay. Repeat the operation symmetrical. This and the symmetrical to this. All right, so since it's gotten it now, then we can now say, okay, escape. We can now say, okay, what will be the true size of it? So you can now use dimension to now say, okay, let it be 4 or 5 or 6, right? So I just wanted to show us that we can actually get this done, in that manner, right? But for the next other ones, I will do normal dimension to save our time. You just click here. You could say 190. Okay. That'll be 116. Dimension from this part. Delete that, do that again. From here to this point. Right. You just say maybe 20. Right. Move this in. It's so using dimension escape. If for dimension, what is this distance? Put that out. You could say 5. So these are different ways you could go about this. I'll show us another one. Let's say 6. And if I'm using this multiple so that we could just see. So we'll go to this other one. I'll probably not even use square again. Let me use a circle. Just for the purpose of the learning, just pick up a circle. I can even come here. Let's do another P for projection. Pick this guy up. Enter. So that when I do maybe a line, I could call this line. I switch to construction. So from here to here, from here to here, I have a middle, right? So you just pick up your circle and drop and switch it back to normal circle. See, there's another way you could also go about it, right? So I just use these 3, and then for this one, all you need to do, you won't do all those things, just to specify what, maybe distance and the radius. In this case, this would be diameter rather. Okay. So all 3 of these, they have their specific use cases, or where you are limited, you can't use this, you can use the other one. So I'm just showing us all of that. So having done this, let's quickly move. Having done this, the next one is to map out this cooling region, the places we want to really do this stuff. So I just turn on my body, pick up another rectangle. We just do this one's going to be a construction line as well. Just trying to map it out first of all. And then turn this off. And then see what's happening there. This is the transformer. This way ends, right? But we don't want to also be too. It's not as if we are trying to have a see-through kind of hole. As long as the air is able to, just enough amount of, air is able to come in and go out, because it's just simply air differential, like hot air, warm air. Warm air is at the region where you have the heated components, the heat sink, the transformer. Then the cool air would be just at the surface or the top there, outside that enclosure. So there's going to be that, because of the temperature difference between both of them. From your knowledge of maybe fluid, you will know that the hotter air is what lighter in density, has a lighter, is lighter. While the cool air, what's it called? The one that is cooler is what dense. So what will happen is the light one, light that's a hotter air will be moving up, right? While the one that is cool will be sinking down. So that circulation of I'm going up because I'm hot, you're going down because you're cool, is simply what, that's how your, natural cooling convection what takes place, right? So that's how you're going to have that exchange, cool air coming in, hot air going out. So I just had to explain that. So simply we turn back on your top, and then we can just do to also be specific, so I don't have very unstable sketches. So just move this out and call this 10. Right? What's the actual distance? Right, you can call this. Let's turn that off again and see what's happening. That's too much. Okay. So just say 60. Right? Let's see if that works. Okay. So we could say 65 rather. Then for this other region, as from here to this part, you could just say, let's see what's happening with the transformer. So turn this all back off. Okay, that's fair enough. So we could say 75 as well. Okay, 75, right? Sorry, that was meters instead of millimeters. My goodness. Let me just remove and do again. Okay, so just click on this. That was 75 meters, that's why. So you have to do sorry, and then we are back to this. All right, so the next thing is for me to just pin this guy. I don't want you to move around. So I do this. All right, you can see it's fully constrained now. Let me turn this back on to see that it's okay. So I can just leave it at 28. I don't know if you're seeing my thought process while doing this. I'm not making it very constrained, but I'm actually having some thoughts while doing this stuff. That's exactly also what I will also like us to adopt. So now we've gotten this PCB can just hold on for a bit. Sorry. The PCB can hold on for a bit. Now we have this on the top, right? So we'll come over to solid. We'll perform one operation. So pick this up, pick this up, pick that up, pick everything here up. So the first one will be, we'll create the hole first of all, right? What I just did now is what? I've selected the inside to be where it stops. But just to show you, you could just say to objects, when you come, you now what? Select the inside to still give you the same thing. But this is more specific. So you click on OK. So we've had the cutout. See the three different cutouts we use. All right, so the next one I will be to go back to that same LED guy. All right. Use that same sketch. Extrude, use that same sketch to form a body. All right. Same sketch. Same sketch. Pull it down. I'm sorry, selected the wrong one. Same sketch, same sketch. This one is not there. One, two, three, 4, 5. So put this all the way in, but this time around, it's not going to be a cut operation. We actually need that body, right? We need it. So we'll do, it's not going to be joined, new body. Are we together? New body. And then where will I stop? Distance to object, where? I turn on my PCB to know where. You can turn this off just for a moment. So I will say, okay, when you reach the first surface of the PCB, you stop, right? Are we good? I will now select back that body. Now for this one too, you probably also want to, it's very important that you also have that offset. So we can use clearance here, clearance. So it's not hitting directly on the components. Are we together? So once you're done, you could just select OK for now. So every other thing, okay, let me add one more, then I'll pause for questions, because every other thing we did is just to make this guy look functional and useful and appealing. So one more thing we'll add here is what? The vents now. So it's still the same guy, same sketch, edit. Go pick up your slots to make life a little easier for you, so I don't need to create circles and turn and put circles and lines to get the same thing that you have done with already made tools. So that's my slots. I picked my slot. Then I will do D for dimension. I want to constrain this guy to just be 3 mm away from that side and 3 mm away from this side. That's why I did that line, just to use it to guide me. So 3 mm. Right. So the next one is how long will it be? Put it together. So I'll just say okay, about 10. Now do not forget when we talked about IP rating. We said IP30, that was the specification, right? So I'll just show you something. Now this whole, if someone can decide to make it as big as, but since we are using IP30, IP30 say okay, as something as up to the depth. sorry, an object of size 2.5 up will not be able to penetrate, as it cannot go in. These are actually small. Don't forget, this is fusion. You're magnifying and you're saying these things look bold. But if you can already sit down where you are and you're picturing, you're having that mental picture of what 2 mm looks like, then you know that, yeah, we're really talking something that's, you even need probably glasses to see through, right? So it's small, but not that small anyway. But so you don't want something that's from 2.5 up to penetrate, that's to go in. But from something that is lesser than that will go in, right? And then another thing, since we say 30, 30, the 0 at the back, that one is it represents fluid penetration, which we all discussed yesterday. So I'm not really going to the depth. So we all say for the number 0, it means it is not protected against any fluid. So yes, definitely fluid can also get in. Are we together? So we are now constrained. So since we are using IP30, then by that we cannot allow this hole to exceed. That's this the radius of this slot. So if we are to look at, let's say, 2.4 divided by 2, that will be what? 1.2. Remember, this dimension is not a diameter, it's actually a radius. This is like, how it's done in engineering from this point to this point. So since the radius, that means you have to also consider the overall, which is diameter. So I will do 1.2, but I'm trying to achieve 2.4, right? So that's how it will look like. So we've gotten one slot, and that's all. So we'll just do extrude. Same extrude cut operation, right? Operation cut. You can turn off PCB for now, so don't damage things. You move in there, you set to objects, and you select the inside as that's the object you're talking about. So now we have just had a vent. We've just had one. But of course, we all know how this is. It's not just usually what's going to be one. This way. Okay, sorry. All right, it's back. So we now do what? We now use a pattern to now have the numbers and the directions of that, of that slot, that vent now we're trying to create. But of course, this one will not be enough to allow the whole, what's it called, the air coming. Remember, we say significant amounts of what cooling, right? So we say future. What's the future now? Extrude. As this, we'll say this part and this part, right? So I can do this and I can do this. That's what it means. So once we've gotten that, go over to how many do I want? Okay, for this direction, right? So let's open back our PCB. Turn back PCB on. And okay, don't even need the PCB now. Since we already had this sketch, you can use this sketch to look at that, what's happening there, right? Can you see? I use this sketch to know the boundary. So we can just say, okay, for this part, the one going this way, we could say 4, right? And then the one going this other way, if you're please, let's see what 10 looks like. All right. Okay, where's the parameter there? So minus what did you have there before? I think it was 70 minus 65. Okay, not much. And the reason why I'm guessing the value is because I did not actually measure. We didn't take measurements of this line, but if we have that, we can use that to know the spacing, right? But of course, I'm showing you so that when you're doing yours, you could take time to get it done. Click on OK. We've gotten that out. That's our vent, and that's what the component looks like. Now I will pause here for one more question before I do the final thing on this part, and that will be where we will round up for the enclosure, right? So like I said, you see what I've done here? This one I've done here, you will replicate it on the bottom, right? Because it's going to also get very pretty warm and hot in there. And if you don't forget that there is no vent at all at the bottom. So it's as if you're cooking something there. So it really does need that vent as well, right? Don't forget use case. There are cases where you don't need to do that, right? So I'll pause here for question before I do the very last, the very last thing, and then we round up. We are done with creating enclosure. So are there any questions?
Please, you talked about IP30. You talked about IP30, the ratings. That's 0. You said it's for fluid penetration. Please, can you explain what that means?
All right, so I didn't get your name. What's
My
the
name
name?
is Chizaram. Chizaram.
Oh, okay. All right, Chizaram, thank you for your question. So, like I said, these are like standards that you use for when you for products. Like each product has, a range of. If you're trying to do a project that will be used in-house, for instance, or something that will be exposed to harsh weather conditions, like there will be lots of maybe humidity or dust and stuff like that. So those things are standards. It's not even something you need to cram. You just go in, you pull it out, and you see what works for what. Do you understand? Now, for the number, because I believe that's what you're asking. For the numbers itself, they also have it just like when you see, like you say, symbols, and then you interpret the symbols. So if you're talking about ingress, ingress, you understand, protection. Now, well, we also have other ones that are used, like I mentioned, European settings and all of that. So if you're talking about ingress, the IP rating now, the first number that you have there is used for the objects penetrating, you obstructing against objects going in, or you providing means that, okay, these objects cannot penetrate, right? So 3, 4, 5, whatever it is, all have meaning. Like I said, 3 tells you that if something is smaller than 2.5, it will pass through. But if that thing is not smaller than 2.5, it cannot pass through. That's what the 3 now simply represents. Now, the second number at the back is for fluid penetration. It's not just water. It's just like, what fluids are now. So just classify them and put them there. So it could be airtight, it could be maybe dust tight, and whatever it is. So 0, which is the one we are having as part of what we are using now, tells you that there is no protection. No, it's just there. Nothing is not protecting anything. That's 30 now. Do you understand? That's how it's interpreted. So there are many numbers. Like I mentioned, even I think Mr. Felix also did a good explanation for that yesterday. You understand? So all of those numbers have meanings. If it's something that, probably don't even need dust to go in, you're looking at IP6 something, because from 6, that's why you're saying, protection again. In fact, even physical objects could not go in, even fluids could not go in. And then those other variations, a fluid that is pumped, pushed to it at a certain angle, or a fluid that is maybe dripping, can it pass through? All those ones are the variation where you see 6.5, 6.3, 6.4, depending on that. So I believe I've answered the question, so I don't need to, go to the. Hello, can you confirm? Are we together?
Yes, yes, together.
So I can proceed, right?
Yes.
I'm not hearing you.
Go ahead.
All right. So, like I said, I've already showed us some things I'm expecting to see on our. I will actually inspect our designs. So, we didn't get your numbers for fancy. We are taking our time to make sure you're getting recordings and all of that. Someone even asked for a slide. I said it's also made available in due time. Just ensure that you're able to even round up what you're doing first. So, I would like to see what some of us are able to do with these things, that all this knowledge, all these things have been poured. I like to see your own variations. I don't like to see you just copying and trying to replicate. You could replicate, that's fine. But after that, what are those other things you feel, maybe you would have done it this way? Like the first person mentioned about the nose and the groove. As for the locking mechanism, now the snap fit. That was a very good example. Why segments? Why not make it round? You understand? All right. So having said that, I will just do the last one. Remember, we say cost effective. So I'm looking at the case where you just put this in the machine, print it out, and you put it together. You are gone. Everything is fine. There's no need for trying to go and buy one specific thing, maybe on AliExpress and all of that. That's why I'm just doing some things as basic as it could be. So for this point, you know that this is the region where we are supposed to have to see what's happening with the LED. understand? The electronic personnel will probably explain to you why you need to see what's happening, right? I won't go there. But you just know that physically on your own as a user, you're supposed to be seeing that blinking, just like you see the lights on your phone and the rest of that. So first of all, you can see body 1, 2, 3, right? So I will just do what we did earlier on, hold my shift, come here, and then I will call this transparent, right? And transparent, what's it called now? Okay, let me just call it protrusion for now. For lack of a better word, please you can name yours better. So it's just basically where the light will pass through. It's going to help, you know, the lighting is down. So it's going to also help channel that light from where it is all the way. You know, those things they normally put in touch that will help make the lights have more, become even more like amplify the what's it called, of the lights now, how bright it is, you understand? So that's probably what you're going to be using for this material. So you just come over to this point. Maybe at this point you could just try doing something like this. Could say right click in properties, right? And so we just run over, just trying to show you so that when you're on your own, you could, you know, play around with them. You could just come over and then say, okay, let's look for plastic now. Sorry, plastic, that's it. And then you will say maybe, don't forget they also be printed. That's why you're seeing them, they have names. These are all, most of these are also what, you know, filaments, and some of them are resins, and you could see them here, right? So let me just say PET, for instance, right? Just to pick something for us, and we just come over to this guy and drop it over there. See, I'm dragging, I'm dropping. It's quite easy, as simple as that. So it's as if we have a hole, but we actually know that it's not a hole there. It has what? It has what? Something transparent. So for yours now, probably I will charge you to, before adding this thing, this protrusion, you might want to fillet this region. Let me show you something. That's why I'm still talking about maybe beauty now, in terms of beauty. You might want to fillet this region, something like this, right? I won't do that just to show you. I'm giving you things you could play around with. A little bit, right? Not the one on the top, oh, the one on this other surface, right? So it's going to actually show you, for instance, let's pick the round one. Let me implement that on the round one. If you come here now and do something like this, right? You know how it is normally on your bulbs now, and then you now do this protrusion here. You can already see that it's going to add some form of beauty to it when you're maybe probably trying to do your rendering and other stuff. Like they also have use cases. This is what it's going to look like, right? So you probably also want to do that because actually it's also necessary. You don't want it to, except maybe you just want everything to be very flat, right? Else, you probably want to also what? Make that region look a little better. So now we have these three components, transparent protrusion, this, that. So we'll come over, turn off the bottom. We do not need the PCB for now. But there's something we need to do. Question, how do we inside, how would this just go in? Can you see what's happening here? Does it make sense? Would it just go in and stay? No, of course, right? So what am I going to do? First of all, I can come over to this point. Let me turn off this. This is what we have. They're just like straight blocks. I hope the transparency is not going to cause confusion. So I could just come over to this point and do a shelling of each and every one of them. Right? Sorry. I'm trying to achieve one. So I'm trying to achieve one. So I'll use 0.5. I have to have that one there. So I'm shelling. Take note how I'm shelling. Let me say 0.5. I'm selecting just this face. So it's picking up this point. I'm still allowing the objects to remain. Right? But if you're shelling and then you select the entire thing, it will become enclosed at the bottom. Let me show you what I'm saying. Let me change this view. Or let me change just one of them to maybe normal. So I'll change one of them just to a normal stuff. right? So now we can see what I'm trying to say now. Can you notice the under is open? But if you move up to the top, it's closed. That's because when shelling, I just pick the bottom here. But if you're shelling and you pick the entire thing, it's going to shell, or you know how we did the enclosure itself. It will shell low, but it will close up this place. You now have to come and do an extra work to open it up. All right, so we'll come over again, pick up another shell to yeah, just the space. That's what I'm trying to say. Not do 0.5. Click on OK. All right, so we are done. That's one. And the second one, I asked, how are we going to grip this to this other top? How are we going to grip this to this other top? Which are almost rounding up for this session. So one simple way is you can produce a means of using what adhesion. Since it's not there's not much functionality going on there. It's just a part that will just channel the light from the bottom to the top. You understand? So what we could just simply do is come over to this point. As underneath, create a sketch. That's a very simple approach. I'll pick up your circle. Sorry, wrong point. Pick up your circle, select pull out. We'll give a dimension. You can pick another one. Right? Okay. See, I'm tracking that. See, I'm tracking from the middle of the rectangle without using my lines. So you should also be good with that as well. So I'll just do the escape D for dimension. All right. 7. Sorry, I will call that 10 mm. And so it doesn't clash. Same thing here. So we just do equality. Remember, I've showed us how now. Just click, drop. The reason why it's doing this way is because we have not really done that full constraint. It's in the middle, but it still has freedom, right? So for this time around, I could just, for the purpose of the class, I pin the middle. I've shown you how to use a fix now. Sometimes it could also come in handy. If I fix this middle, automatically everything is held in place. So I will just do extrude. Now turn off these top sides because it's very tricky, so it doesn't get fused. If you notice, this is what we are trying to do. This is where our sketch is. See the plane where our sketch is. And then, so we just pick up that selection. So come over to this point, pick everything there. Pick everything here. Pick everything here. I will pull. So what is happening there? That will be the reinforcement. And that will be you also provide us with the, so we could say shell. We could say shell times 2. Don't forget, it's not that big. Shell is 2 mm times 2 will be 4 mm, and 4 mm is not that big. So shell times 2, and I will say join. So if you notice, this is what it looks like. And then this can now provide you the point where you could use an adhesive on this surface and do a direct gripping. This is a very simple means of achieving this, and do a direct gripping to this top, right? Like I said, there's not much functionality there, so that can also work. There are other means as well. So we have 1, 2, 3, and then I think everything is on track. Let's turn on the PCB. Let's turn on the PCB and see if we are good. If you zoom in, right, see the channel, something here. This is a very basic way of achieving that. More like as if you want to do maybe a DIY, you don't want to have to spend much on getting this kind of thing done, right? So having said that, I think I will just finally group from here to here, because it's also one family, right? It's one family, and this one will also change it back to the material that it initially was, which is what PET. So guys, we could just do a quick one. Click on A shortcut for appearance. So this one is different from the first one you saw me do. That one was material. I was specifying that the material is plastic or iron. So you know how it works. If it's plastic, it will have properties of plastic. Fusion will take note of it. But this one is appearance now. I'm just saying, okay, maybe I want to add color, paint. Oh, look like this, look like that. So just to be on a quick one, we'll just say, let's go for actual coloration. Paint. Let's just use paint. Maybe a glossy one. So I can just pick up the black and place. And this is not visible because it's not active. And I could just say maybe, okay, like what we had on the screen. So we just use blue here. Right. And turn on the final assembly. Guys, click on save to save our work. Very important when you're working, always save. And this is what we have been able to do. Just to quickly show us how I inserted the screw, right? So just a quick one. We are done with this session. So just when you head to your design, you could just turn off the top and some of these features. So there's something called insert, right? So earlier on, we used to use the insert manufacturing parts or master card. And then somewhere along the line, last year, Fusion decided to add this to us. This is the insert fasteners. All right. Thank you so much. So just a quick one. Just wanted to show us how we inserted the screw. All right. So I said earlier on we used to use the insert master card and insert master manufacturing parts to do play around with some of those accessories. Last year, Fusion came up with the insert fastener concept, which actually made it very very easy for us to bring in screws. And the good part of it is that it's automatically ties the joint for us as well. So it gives us a lot of flexibility. So you don't need to waste your time on making things like that or trying to model stuff like that. So a quick one, we just head on to, we are working with the ASCII metric standard, and of course we are looking for a screw. So I'll just select a screw. Let me pull this a little down. So a round head screw. So I'll be using the cross recessed pan head machine screw. So upon selecting this, now it gives us the dialog box where we can select the size. But where you see your nominal size, this is where you can now say, okay, since you're working with M6, so you pick up your M6, and then the length 18 mm. And you could also look around with the material and all of that, but we just leave this on default for now. And the finishing as well. You could also include your part numbering so that you, when creating your bill of material, those things will be included. So I haven't selected all of this. All I need to do is just to move in. This is how effective this is. Very simple. Just move in, make sure that Fusion is able to, that's why we are using holes, right? When creating stuff like that. Because if you're using something like maybe an extrude cut to achieve this, it could, be troublesome sometimes. So since we use hole and then the hole is also a standard hole, a threaded hole. So bringing this our M6 here, Fusion will quickly pick what is happening there. So can you see what happened? Just select. And the beauty of it is that everywhere on this board that has that same size is an automatic selection. If you notice, I just selected one, but we'll have it everywhere. So if I click on OK, and that's how easy it is. I've been able to put on 4 screws with just one step, right? So I just wanted to show us that because it's quite what's important. Sometimes we could waste a whole lot of time, trying to get things like this on. If you notice, if I zoom in, you will see this. This means that there is also a joint assigned as well. So it also knows that it's not just staying there, but it's actually gripped to the system. So it makes life, way easier for you. And you can also, maybe if you made a mistake, head on to here, right click, and then edit the fasteners. So I will stop sharing this Fusion. I just wanted to show us this. I think that was the last thing remaining.